Okay, so just a quick review. So far we've learned 4 different types of ways that we prove that 2 triangles are congruent. Side, 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 angle, side, angle, angle, side. And the last one is angle, angle, side, angle. Remember, this is not a way to prove that 2 triangles are congruent. So let's look at the following triangle here. There's 2 ways to prove that this is congruent. Okay, so I'm going to determine both proof, and then you can write a proof demonstrating one of the ways. All right, so the easiest one that I see is that this is going to be the reflexive property right here. So I'm going to mark this with 3. So I can say that these can be proven by S, 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 because I know that 3 sides are congruent. And then the other one that's a little bit less obvious is if you look at these 2 angles here. They're vertical angles. So then I've got side, angle, side. So the other option is side, angle, side to prove that these 2 triangles are congruent. So this one I would use vertical angles in my proof, and this one I would use reflexive property. So I could say that to do my proof, I would first have to label my side. So I'm going to erase. Try it again. Okay, so if I call this A, B, C, and I'll call this point D, right? I can say for my statement, and this would be my reasons, I could say that AB equals BC, and I would say that's given. I can say that AD equals DC, and that is also given. And then I could say that BD equals BD, and that would be reflexive. And then I could say that these 2 triangles, ABD is equal to CBD, and that would be by side, side, side. So that would be an example of a proof to prove that these 2 are congruent. Okay, hopefully at this point you can do that on your own. If you want to check your homework, the answer should be written on the homework board. On the side, check to make sure you got everything correct. If you have any questions, let me know. All right, so this would be a pair share, but since we're doing it in video format, what I would do is pause the video, try it on your own, and then come back to see that you've done it correctly. So this says in triangle ABC, label the legs and the hypotenuse. Be ready to explain how you identified each side of the triangle. So you're going to do the explaining in your head, but I know that the hypotenuse is always the side across from the right angle, so the rest of these are legs, okay? And I use, to find a missing leg, I use C squared. Remember, the hypotenuse is always C, and this is side A, and we'll call this side B. Does not matter. C squared minus, say, A squared is going to give you B squared. And so then the last step would be to take the square root of B squared. All right, so let's look at what we got here. We got 13. This I'm going to label C, because it's my hypotenuse. And I'll go ahead and label this A, because I know that, and I'll call this side B. So I would do 13 squared minus 5 squared. And when I do that, I get 12, or I get 144. And the square root of 144 is 12. So that missing side is 12. And then I'm noticing the same numbers here. So I'm just going to say that this side is 12 because I remember that corollary, that if 2 sides are the same on a triangle, then the third one's the same as well. Actually, I can't use that for this, sorry. I just know that this is Pythagorean theorem. I'm going to plug the same numbers in the same formula and get the same answer. Over here, I can't do that, but I know that this is C because it's across from the right angle. So this I'm going to call A, and this I'm going to call B. So I've got 10 squared minus 8 squared, and that is 36. And then the square root of 36 is 6. So I know the final side is 6. So which of the triangles above are congruent? Well, number 2 and number 4. And I know that because they have the same sides. So if 2 triangles have exactly the same sides, then we know that they're congruent. So how do I know? I would say by S, S, S. let's move on. Let's consider these triangles here. Do we have enough information to prove that they're congruent without finding the length of the third side? Well, the truth is, yes, we do. We know that the hypotenuse is the same, and we know that the leg is the same. So when we plug it into the Pythagorean theorem, in both instances, we will get 12. And what we call this is HL. If you know the hypotenuse and a leg, you can automatically assume the two triangles are congruent. However, in order for there to be a hypotenuse and a leg, there must be an indicated right angle. So hypotenuse leg postulate only works, the hypotenuse leg theorem only works on a right triangle. And basically what it says is that if you know that there's a right triangle, and you know a leg is congruent in both triangles, and you know the hypotenuse is congruent in both triangles, you can say both triangles are congruent. And if you're given that information, you can say that a triangle is a right triangle because if it has a right triangles are congruent. Okay, so this will be your given conclusion. Okay, so let's see if we can use HL congruence theorem to prove the triangles are congruent. If not, you have to discuss what else we need to know. Okay, so the first thing I know is that if this is a 90-degree angle on this side, then I know that this one also is going to be a 90-degree angle because they're adjacent angles, and they have to add up to 180. Okay. Then I also know this side is C and this side is C. However, what information they did not give me is another. Oh, they did actually. I'm sorry, I had to look closer. Is that this side as well is going to be congruent, and that's going to be my leg. So yes, you can use HL in this case. Now for this triangle here, this is actually a trapezoid, but we're looking at the two triangles on the outside. They did give us the right triangles. They gave us a leg, but we don't know what C is, and we don't know if C is congruent on both triangles. So this would be a no. What they would have to give us is that these two are congruent. If they did that, then yes, we could say that these two triangles are congruent. All right, so let's look at what a two-column proof would look like to prove that these two triangles are congruent. So the first thing I'm going to do is read my givens. So it says FE is perpendicular to DG, which is why we have these two right angles marked. We also know that E is the midpoint of DG, so I can go ahead and mark that these two sides are going to be congruent. Okay, so we want to prove that these two triangles are congruent using HL. Okay, so the first thing I'm going to do is read my given. So I'm going to prove that FE, and that's given. Oh, it says a two-column proof. Sorry. Redo this. Two-column proof. Statement. Reasons. Okay. So one, I can say that FE is perpendicular to DG, and I'm going to say that is given. Number two, I can say that FD is congruent to FG, and that is also given. So I'm going to mark that here and here. Okay. So the next thing I'm going to say is that angle E is 90 degrees. but I'm going to have to say, angle FED is 90 degrees. So FED is 90 degrees, and that would be definition of perpendicular. And then I can say angle FEG is 90 degrees. And once again, I'm going to write definition of perpendicular, because perpendicular means they form at a 90-degree angle. All right, so now I know that. So now I can say that angle FED is congruent to angle FEG, and that's because all right angles are congruent. Okay, so now I know that these angles are congruent, and I know the two sides are congruent. And so the last thing I can say is that I can say that triangle FDE is equal to triangle FEG, and that would be the hypotenuse leg theorem. That tells me that those two are congruent. This was a pretty complicated one because you had to know how to kind of work out the angles are congruent in the middle. That's how it's done. Let's try some more. Okay, so here we're going to be looking at, I'm going to stop the video here actually, and you can go on and watch the second video, and that one's about corresponding parts on corresponding triangles. So we've just proven HL, that means that if you know a hypotenuse and a leg, and you know that it's a right triangle, you can prove those two triangles are congruent. And you're probably going to be using the definition of perpendicular quite a bit, and all right triangles are congruent. Okay, so I'm going to pause, I'm going to stop this video, and you can go ahead and conclude with the next video.